So far in this course, you've seen that methods do all of the work in an application. These methods are basically blocks of code, which are instructions on how the program will run, right? And you've seen that methods cannot be run independently on their own, right? These must be part of a class definition. So when an object is instantiated, methods can be invoked on that object. For example, let's take a human class, right? A human object. A human can walk or eat. So the block of code responsible for walking or eating is associated with a human instance, a human object. And the instructions for how to walk or how to eat is coded inside of that human class. So walking and eating don't exist independently on their own, right? These behaviors do not exist outside of a class. It's associated with a human class. But here's the thing. In Java 8, the designers of the language introduced the concept of something called functional programming, which does allow methods to exist independently on their own. And you'll see exactly what I mean when we get into the code. These independent methods are often called functions. All right, just keep that in mind. This is a new terminology that I'm about to introduce to you, functions. And this all comes from functional programming. In functional programming, blocks of code do not necessarily need to be wrapped inside of methods belonging to a certain class. It's totally possible for blocks of code to exist independently on their own without being associated with any class definition. Now, this Java 8 enhancement provides a tremendous amount of flexibility because you can pass these blocks of code as arguments to methods of an object, right? Or give these blocks of code names and invoke them independently as you please without first creating an object of any class, right? So to summarize, in Java 8, the need for some functionality to be associated with an object is no longer necessary. This new freedom comes from a new language feature that was introduced known as Lambdas. Lambdas allow us to create independent blocks of code that can be run on their own, right, without being associated with any class. So before Java 8, in Java 7, Java 6, the closest thing we had to functional programming was anonymous classes. And I covered anonymous classes earlier in the course, but let's review how anonymous classes work, and we'll then convert that code to a Lambda expression, and you'll get a better understanding of how Java 8 Lambdas work. So let's get started. I'm going to create a new project. We'll call this Lambda-practice. And just hit finish. Click on Don't Create. And here is our Java project, Lambda practice. So right click on source and go to New Class. And then type in the human class. And hit finish. And here's our human. Now let's create another one. I'm going to right click, go to New Class. And let's make a robot class. So we've got the human and we've got the robot. So robots can walk, and so can humans. So I'm going to define a method, public void walk. And we could just say that robot walking. Okay, that's all we're going to have. I'm going to copy the same method and paste it into human. And instead of robot walking here, it's going to say human walking. Okay, so we've got robot walking behavior and we've got human walking behavior. Let's close both of these classes. Now we need another class called application, or I'll just call it the app. And this is going to contain our main method where we can instantiate instances of human and robots. And I'll show you what I mean. So let's create a human instance, human, and I'll call him Tom. And let's make Tom walk. And similarly, we can make a robot and we'll call him Wall-E. And make Wall-E walk. So let's run what we have so far. This is basic stuff and see the output. Now let's create a method outside of this main method and we'll call this walker. So let's just say that it accepts a human and it'll make the human walk. We could just call walker like that and pass in Tom as an argument, and walker will make Tom walk. Now the thing is, walker can only make humans walk. What about robots? We have two options. One, we can have a parent class and have that parent class be the argument type. And this way we can make human as well as robot be passed into Walker, and Walker can make both of them walk. Or we can create an interface and have both human and robot implement those, implement that interface. So let's do that. Let's actually create an interface. I'm going to right click here, go to new interface, and I'm going to call this walkable. And this interface is going to have one method, public void walk. It doesn't accept any arguments. And so if we make human class implement that interface, make sure you don't miss that S there, implements walkable. And we make the robot class also implement walkable. Now, instead of in the app class having human be the argument, we can make the argument walkable. Walkable entity is the argument name, just to be explicit. Okay. And now we can pass in Tom as well as Wall-E to Walker. So let's take this Wall-E and paste it here. So now the same method is being used for both a human as well as robot. This is known as polymorphism, right? And we've covered this before much earlier on when we were talking about object-oriented programming. So this is also a quick review of that concept, but it's closely related to how Lambdas work. Now, where do anonymous classes come in? Well, anonymous classes, if you recall, is creating a class definition on the fly. So for example, if I invoke the Walker method, right, it's expecting an instance of a class that implements walkable, right? That's what this method expects. So instead of creating an instance of an object first, such as human, robot, I can create a brand new object, and we can say new walkable, new walkable, an instance of that interface or a derivative of that interface. And now hover your mouse here and it's saying we need to add the unimplemented methods. Which method is it asking us to implement? The walk method. So let's click on that and notice that it fills that out for us. So now we could just make this be any entity. So we could just say custom object walking. So on the fly here, we're creating this walkable class implementation. We don't need the class name, right? We don't have a specific robot, human, or animal. We're just saying we don't care what it is. We just want a new instance of a walkable entity, and we'd like to invoke the run method on it, or the walk method on it. And so that is what's going on here. So if I comment out, let me comment out the robot as well as the human so that you can see that this is also going to run as expected. So right click here, go to run as Java application, and notice it says custom object walking. In Java, everything is an object, right? So you can't have a particular functionality be segregated or pulled away from a class definition. This is basically the only way to do this before Java version 8 came around. So this behavior, this walking behavior, is not tied to any class definition, such as a human or a robot. We're basically creating it on the fly here and passing it to the Walker method. This is the closest that Java version 7 and before came to functional programming. But in Java 8 and onwards, they introduced the concept of lambdas. So I'll show you how lambdas work. To convert this to a lambda expression, it's actually very simple. We first get rid of this. We don't need this. And I'm going to get rid of this as well. And we don't need the walk method definition either. Well, let's just get rid of that. We just care about the behavior. What is the behavior? The behavior is this, some custom object walking. We want that printed to the screen. So let's move all this to one line. Okay. And I'm going to close out this method invocation here. And now we don't even need these curly braces. And all we need to do is do an open and close brackets and create an arrow that looks like this. And there we go. We've done it. We've converted an anonymous class definition to a lambda expression. This is known as a lambda expression. So we don't need a name of the method, right? The walk method is no longer defined in the body of this. We don't have to have public or void or any of that. We're just wanting to execute this behavior, right? And it doesn't have any arguments. So we're just saying, okay, just do this, whatever's here in here. And so this is known as a Lambda expression. This syntax is very succinct. And this is, basically a shortened version of the anonymous class definition that you looked at just a moment ago. So what are the mandatory parts for Lambda expression? Well, we need this arrow, okay? If I get rid of the arrow, we're going to have a problem, all right? So let's have the arrow. And I also need this open and close parenthesis. If I get rid of that, that's still no good. I need to have that, so let's put that there. And then finally, we need to have the actual command. If I get rid of this, it doesn't know what to do. What is this arrow doing here? So we need to have the actual steps that need to be executed. Now, these steps could be multiple steps. Right now, we just have a one-liner, one command. But if we have multiple things that need to be done, we wrap them in curly braces, like this, okay? So inside of these curly braces, we have the steps that need to be run. And you put a semicolon inside of this. So we can have multiple things going on as part of this Lambda expression. We can have loops and if-else statements, all sorts of things. So remember, if we have just one line of code, we don't need these curly braces. But if you have multiple steps that need to be run, multiple lines of code, we need to include these curly braces as part of that Lambda expression. So you might be wondering, what is this thing inside of the argument for the walker method? We are passing this Lambda expression. What is this? This walker method accepts an argument of a walkable entity, something that implements the walkable interface. This is an implementation of the walkable interface, believe it or not. That is why we're able to pass it as an argument to the walker method. And I'll prove it to you. Let's get rid of walker here. We're not invoking the walker method anymore. I'm getting rid of that. And remember, just a few moments ago when I was talking about functional programming, these functions could be passed in as arguments to other methods, and I showed you how to do that just right now, as well as you can create these blocks of code and assign them to a variable. So let's assign this thing to a variable, and I'll just call it a block of code. Okay, so I'm assigning all of this, starting from these open and close parentheses, all of this, I'm assigning this to this block of code variable. And anytime I need to refer to this behavior, when I want to invoke this behavior, I can just refer to a block of code and just pass this thing around as arguments. Now, what is this thing, you might be wondering? Well, this thing doesn't have a type. This is still Java programming, don't forget. We need to specify the type of variable. So what is the type for this variable? Let's create a type so that we can give this block of code a type. So let's do that. Let me right click here and go to new. I'm going to create a class and I'm going to call it a Lambda class. So let's hit finish. And so this is our type. Let me close this and let's refer to that a Lambda class. And so now notice it's no longer giving the error on the variable name, because now this expression is legal in Java. We have the type as well as the variable name. But the problem is right here. It's saying the target type of this expression must be a functional interface. So what does this mean? Well, this means that we need to have an interface type. We can't have a class type, okay? So we need to create an interface. So let's go back to this Lambda class and let's turn this into an interface. I'm going to do public interface. I'm going to rename this to a Lambda interface. Okay, so I'm going to hover my mouse here and rename the file. Click on the first suggestion here, rename the file so that it's now named a lambda interface.java. Okay, so now instead of referring to the class, we can say a lambda interface, and let's hover our mouse here, and it's still complaining. It says the target type of this expression must be a functional interface. So we got the interface part out of the way. What does this functional interface mean? What is this? Well, a functional interface is an interface with only one abstract method in it. You need to have an abstract method in that interface. That's what a functional interface is, okay? So let's go back to that a Lambda interface, and let's create just one abstract method. So it's going to be public void sum method. All right, it doesn't accept any arguments, and we don't, of course, give a body to this. This is a functional interface. All right, and let's hit close, and now notice it is compiling. Okay, so now you should understand that a Lambda expression can be given a name. All right, this particular expression, starting from this open and close bracket, all the way down to this curly brace here, this is a Lambda expression, and it is being assigned to a variable, which is called a block of code. And this variable must have a type, right? We need to give every variable a type, and that type is a functional interface. So it's very important to understand that Lambda expressions, their type must be a functional interface. And again, what is a functional interface? It's an interface with just one abstract method. So that is a minimum requirement for a Lambda expression. So now you must be wondering, when we were passing that Lambda expression into the Walker method, right? We didn't have a Lambda interface at that time, right? We were just passing in the Lambda expression to the Walker method. Let me bring back your memory here. Let's invoke the Walker method. And in here, we can pass in the Lambda expression that I had earlier. Right? This is our Lambda expression being passed in to the Walker method. What does the Walker method accept as an argument? It accepts walkable. So when you look into the walkable interface, let's open that up and boom. What is this? This is a functional interface, isn't it? It's an interface with just one abstract method. So it's perfectly legal. This is working perfectly fine. If we go back to walkable and I create another method in here, let's just do public void run. All right, this is another abstract method. Save that file and notice we've got an error. Go back to the app class and it no longer compiles. If you hover your mouse here on this error, it's saying the target type of this expression must be a functional interface. Okay, so walkable is no longer a functional interface because it has more than one abstract method defined. So let's get rid of this and turn this back to a functional interface and hit save, and there we go. Now it's compiling. So that is why we were able to pass this expression to the Walker method. Now let's come down here and invoke the Walker method again. And this time, instead of passing a Lambda expression, I'm going to pass in this variable. What is this variable? This variable is a block of code, right? It points to this Lambda expression. So I could just pass in that block of code to the Walker method, and you'll see that we can't do that. Let's hover our mouse here and see what's going on. And it's saying the method walkable in the app is not applicable for the arguments a Lambda interface. The reason is because the Walker method accepts walkable as the data type, right? This is still Java. We have to make sure that the types are correct, right? This is a type-safe language. So a block of code here is a Lambda interface type, but we are trying to pass it to a method that accepts a walkable interface, right? Now, it's important to understand that both Lambda interface and walkable are both functional interfaces, but that is not the only requirement, right? So let's change the data type for a block of code. Instead of it being a Lambda interface, let's change this to walkable. And voila, now it's working perfectly fine, right? And now both invocations of Walker are gonna work successfully. So right click and hit run and see that the application is behaving as it's supposed to. So this is the first printing that's going on from this first invocation of Walker. And this right here, these two lines are being printed from invoking this method. So to summarize, if you're creating a Lambda expression and you assign it to a variable, that variable's type better be a functional interface. Very, very important. And if you're going to pass in this expression, this Lambda expression to a method that accepts a functional interface, we're all good. But if the interface that method accepts as an argument is not a functional interface, then we cannot use a Lambda expression like this. For example, let's go back to walkable. We just have the walk method in here. If I create another method and call it run and hit save, there's nothing wrong with this method. This method is going to accept the walkable interface as a type, and the walkable entity could walk and could run. But the problem is here, right? This is the problem. A Lambda expression, its type must be a functional interface, and in this case, walkable is no longer a functional interface, it's just a regular interface with two abstract methods. Learning Lambdas could be tricky for newcomers that are learning Java programming because there's already so much syntax involved in the language, and now you have to deal with a new set of syntax for Lambdas. But don't worry, it just takes practice. I wanted to show you how closely Lambdas are related to interfaces and the concept of a functional interface. That's the basic idea. So if you understand that, you're good to go. We can continue on to the next lecture. We're going to work on more examples using Lambda expressions, and we're going to convert traditional Java methods into Lambda expressions. The Lambda expression that we have here does not have any arguments, right? Those parentheses, the open and close parenthesis, it's empty. There's no arguments in it. But in the next lecture, we're going to get into how to deal with arguments in Lambdas. Recall that the abstract method that we have in our functional interface does not have any arguments either, okay? So try to establish that link in your head and understand what's going on. But if you get the basic idea, you understand that we need a functional interface, and that's what a Lambda expression is an implementation of. You're on the right track. I'll see you in the next lecture. We're going to get a lot more practice. Stay tuned. I'll see you soon.